Mr. McMillan purchased his truck in 2014 for $22,000. In the year 2020, it was valued at $9,100. What is his truck worth now? We'll say now would be the year 2024. This is an example of exponential decay because the price of the truck will decay over time, not at a steady rate, but it'll eventually kind of taper out. Really, to set this question up, we need to organize our information and try to turn it into some x's and y's so that we can build a function like we have done in previous examples. So let's kind of organize some of our information here. We have 3 key points. We have 2014 was worth $22,000. In the year 2020, it was $9,100. And then now, which would be 2024. Okay, how do we turn those into ordered pairs? Well, the yellow one and the blue one for sure basically feel like an ordered pair. The pink one we can deal with in just a second. Let's kind of write this out. 2014 was worth $22,000. 2020, it was only worth $9,100. Sad face. 2024, what would the truck be worth now? I don't know, so let me just put a question mark right there. Now, let's convert these into some actual ordered pairs here. There's my yellow, my blue, and my pink. Okay. Now, I could use X and Y just straight as is. X would be 2014, Y would be 22,000. 2020, 9,100. But having an X value of 2014 is really, really large. And we really don't want to use large numbers when we're dealing with exponential functions. So let's kind of cheat this a little bit. Instead of saying that the yellow X is going to be 2014, why don't we just say that our year starts in 2014? So let's say this. Let's let 2014 be year 0. So let's say my timeline will start in year 0 at 2014. So my ordered pairs would be 0, 22,000. The next ordered pair from 2014 to 2020, it has been 6 years, and now the truck is worth $9,100. The last round, 2014 all the way to 2024, would be 10 years. And I still don't know what the answer is. That's basically what we're going to calculate at the end here. So here's the new version of my information from the original question, yellow, blue, and pink. So from the year 2014, how many years has it been? That gave us much smaller X numbers to work with. It would be a lot less scary to do this kind of question. And we kind of need to have that first X be 0 to make our trick work from previous examples. So we're going to start at the same style. Let's write out our function 3 times. From the previous example, we basically learned that the first round, when I plug in the yellow numbers, I'm going to get my A number to pretty much be given to me for free. If I plug in those yellow numbers, 22,000 for Y times B to the 0. B to the 0 is really just worth 1, so we can cross that off. A is 22,000. And honestly, you could kind of just skip straight to that fact. You could just pull A straight out of the yellow ordered pair like that. Let's plug our A value in for the next function and use the blue ordered pair, 6 and 9,100. 9,100 for Y. A is worth 22,000 times B to the 6 for an exponent. All right, now these numbers are kind of big, so we got to be careful on how we work with this. I need to get rid of the 22,000, and then eventually I need to take the 6th power and get rid of that. So let's do it in those 2 steps. Let's get rid of the 22,000. We would need to divide it away. I'm not actually going to calculate it because I don't really care what that value is. We're going to take the 6th root of it eventually, so I'm going to be lazy, and I'm going to write it like this. I'm supposed to divide by 22,000, so I'm going to write it like that and just leave it alone. B to the 6th power. Okay, 6th power, we need to do the 6th root of both sides. So it'll look a little scary for just a second. 6th root of 9,100 over 22,000. Who cares what that number is? We're going to calculate it. Now, it will for sure be a decimal. So I'm going to put this little approximation. Let's write down at least 5 decimals. The more you write down, the better. It'll be more accurate when you get your final answer. Okay, we need the 6th root. So we're going to press 6, math, 5 in our calculators. I'm going to write that fraction inside the root. So 9100 divided by 22,000. Calculator's being slow on a computer. Weird. I get 0.86318347771. That makes sense because we're losing value on the truck, so it should be a number less than 1, but more than 0. So we're losing about 14% of value every year. I'm going to write down 5 decimals here. Let's say 0.86318. Put dot, 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 show that technically just keeps going. 5 decimals is probably good enough. So I have a B value, I have an A value. We're going to write a function, but this time we have a number that we want to use in our function. So we're going to make the function, and we're going to plug in that 10 for that predict for the year 2024 and get the output for that. So I'm going to use my A and my B and the pink number 10 in this here. So 22,000 times 0.86318. However many decimals you take, probably take at least 5 just to be accurate. And I'm going to throw in that power of 10 because I'm trying to calculate for what would it be worth now in the year 2024. All right, I need to type that expression into the calculator without the y equals. Clear that up. So 22,000 times 0.86318. Calculator is being slow. And then raise it to the 10th power. I get 5,051 and some change. So let me write that down. 5051. It was like 0.686 dot dot dot. Keeps going on forever. Let's round it to the nearest dollar. 5,051 and 68 cents. That would basically round up to $5,052. So my truck is only worth $5,052 compared to what I bought it for. Yikes.